This is Mechanics Chapter 3 course practice. For the most part, the quiz is easy. Chapter 3 requires... It's so easy. Chapter 3 is so easy. Towards the end, it gets a bit tricky because you need to draw FBDs. Well, FBDs are they're very tricky if you don't know what you're doing. But once you know what you're doing and you get the FBD and you understand how to apply Newton's third law, then, or was it third law or first law? Once you know how to apply them, خلاص, everything becomes so easy. Solving becomes so easy. Like a question like this, مثلا هيدا, it was not this one. مثلا this question, وين كان pulley يا عمي calculate equivalent spring constant. هيدا. Like a question like this, where it looks like fancy stuff, I'll wait for it to load. It will become so easy. So, like stuff like this will be so easy. Okay, so let's start. I don't know why SDP is very slow. Which of the following is a non-inertial frame of reference? An inertial frame of reference is anything that's not accelerating. Non-inertial, yeah, it's accelerating. Stationary, is it accelerating? No. Frame perform uniform rectilinear motion. Uniform rectilinear motion means there's no acceleration. Velocity is constant. So, akid, it's inertial. Inertial, remember. Non-inertial means it's moving, it's accelerating. Okay? If it's inertial, it's not accelerating. Please, guys, this question will definitely come. A book resting on a table, of course, it's not accelerating. Floor of a playground is not accelerating. A rotating wheel, it's moving. Ooh, it's accelerating. Okay, أكيد يعني. Question 2, UCM. Remember, UCM has acceleration. The below figure, wait, I'm telling you, I have Ethernet plugged in. I don't know why it's so slow. Oh my god. The below figure shows a trolley accelerating towards the right. Okay, this was in the CA quiz, but many people were absent for it, for they didn't study. So they're gonna see a lot of questions that are kind of new to them. But the CA came very easy. The questions came like the quiz. Okay, so there's a trolley accelerating to the right with a mass m placed against its vertical front surface. Take G equals 10. Before I start this, I'm gonna go back to my اليوم 1. Thursday كانت 31. لا Thursday كانت A31. Wednesday كانت 30. Tuesday كانت 29. Yeah, go back to 29. Over here. I want you to understand that this is how an FBD looks. For example, an object being pushed to the right has, this is its FBD. You always draw it at the middle. You always start with the weight going downwards. Even if it was inclined like this, the weight would still go downwards. But the normal push, it's always perpendicular. Okay? But you should know that the normal push always lies on the y-axis. So if you, let's say you had an object like this on an inclined plane, and you had to draw its FBD, you'd always do this. Start by the weight going downwards, then draw your normal going perpendicularly up, and connect it all the way down. Okay? This is your y-axis. And then draw your x-axis. How you guys know how to draw x-axis? Obviously, you're not going to draw it like this. No, it has to be with the ramp. Okay? X. So many people, they solve like this, by the way, huh? They just use the FBD like this. And I don't like using this. What do? I rotate it a bit. I just make the x like this. Make the y like this. حط normal push here. Okay, and since the weight is a bit slanted to the left, I just draw it like this. Okay, I prefer to use it like this, but many people, they just draw it like this and just solve like this. Whatever you want, okay? But anyway, a typical FBD of an object being moved, you start by drawing your y-axis and your x-axis, label them y, x. Then you indicate the particle by a point. Always start by the weight going vertically down. This is for an object on a horizontal plane. Because the one I drew on the side, the weight was slanted because it was on an inclined plane. Okay, and then you always draw your normal push perpendicular to the horizontal. Okay, in this case it's perpendicular, right? It's always perpendicular. And you have the force, and obviously you indicate, if it's accelerating, you draw the direction of the acceleration, and the friction, always the friction. It's opposing the direction of motion. Okay, you should know, we have rules. Sigma fx, sigma fy. It can either equal to 0, it can either equal to ma. Sigma fx equals 0 basically means that the object is not moving horizontally. Let's say I'm dragging an object to the right. You ask yourself, does sigma fx equal 0, or does sigma fx equal ma? If you're dragging it to the right and it's accelerating to the right, is it moving horizontally? Of course, yes. So we're going to say sigma fx equals ma. Same example, I'm dragging my object to the right. Is the object moving up and down and bouncing? No. So is it moving vertically? No. So we're going to say sigma fy is equal to 0. So you're going to write on your side sigma fx is equal to ma, and you're going to write sigma fy is equal to 0. And based off of these, you solve. أنا هلا I'm going to start solving. Now that you know this, you understand. It's easy for you to solve all FPDs, all شو اسمه all types of these questions. كمان you should know that the normal is always perpendicular to the horizontal base that your object is placed on. So here, because here the FBD is going to look a bit weird. We have the mass m placed against against the surface. So this is mass m, this is the surface here. What is the minimum acceleration that the trolley should have for m not to slip, knowing that the coefficient of friction between the trolley and m is 0.4? If you don't know the formula, go back on the notes 3.6 to 3.8. All that's any important when it comes to formulas is the friction form. I don't know why my computer is so slow. Ya Allah! Oh, I'm about to do backflips. Okay. You can read the notes, or if you want to watch the mechanics CA, just watch the notes part of the video, because I'm not explaining all that again. But you should know that the friction, force of friction, can either be kinetic or static. It doesn't really matter, but it's equal to mu. No, mu doesn't look like that. Mu times the n. Okay, and mu is the coefficient of static friction, which is given. Okay, type look. You have this trolley. It needs to accelerate at a certain speed so that the friction is heavy enough the friction is strong enough to stop it from going down. So always, first step, any question where it has forces, please, the first step, draw your FBD. How's my FBD gonna look? This is our object. You always start with what? Y-axis. X-axis. طيب, تمام. Now we start with your forces. Always, what's my first force I draw? Weight. Always. Weight. طيب. What other forces do we have here? We know that we have the friction force opposing it from falling down. The weight is pulling it down. The friction is going to pull it back up opposite to the weight. So we're going to put up here friction. And since it's staying still, we call it static friction. If you watch the notes, you'll understand what I mean by static and kinetic. If it's moving, it's called kinetic. If it's keeping it still, it's called static. طيب. What other forces do we have here? Anytime you see weight, you should also see normal. But here, what some students will do, they're going to put the normal upwards. Because, Walid, isn't it always in the opposite to the weight? No. I said normal is always perpendicular to your base, to your horizontal. Here, what's my base? My base is the cart. So it's going to be perpendicular to the cart. So it's going to be like this to the right. Okay, so we're going to go back to our FBD. We're going to draw it like this. Normal. طيب. Now we identified our forces. Now everything becomes easy. Everything. This is your first step. Always your first step. Draw your FBD. 2 steps. 2 simple steps. First step, draw your FBD. Second step, do your sigma fx, sigma fy. Let's see. Sigma, let's start with fx. Is it equal to 0? Is it equal to ma? My cart, it's staying at rest. They're saying, well, geez, it's not moving. We're saying fx. So is it moving left or right? Is it? Yes, it is moving right. Because we said the trolley is accelerating to the right. Yeah, it's written here. So horizontally, is it accelerating? Yes. So it's moving. Right. How about Fy? Is it jumping up and down? No. We want it to not go down, right? We want it not to slip. So we want the M to stay at rest. So Fy is equal to 0. Now, this is where it gets so easy. Wallah. Fx is equal to Ma. What are all my horizontal forces? Do I have anything other than the normal force? No. Normal is equal to Ma. This is my first thing. Okay? Second step, Fy is equal to 0. What are my forces? When you say sigma something is equal to 0, that means what's down is equal to what's up. Save yourself time. Don't write 2 equations. بسرعة. If it equals 0, that means what's up is equal to what's down. Okay, so Fs is equal to W. Obviously, guys, we're not going to end here. We can substitute. You can't leave Fs as Fs. You can never leave W as W. What are we going to do? We're going to continue our equation here. We know Fs is equal to mu n. So Fs is going to be mu times n is equal to W. What is W? W is equal to mg. Always substitute. You're not allowed to keep you're not allowed to keep it normal. Okay, never. Fs, always, if it's one big thing, divide it into smaller things. Okay, all. Mu is what? 0.4. N. Can I substitute n as something else? You can say, Walid, n doesn't have a formula. Okay, it doesn't have a formula. But over here, didn't we find that n is equal to ma? Yes. So times m times a. is equal to what? mg. I can't really change anything here. I can cancel m with m, and I can cancel. We're trying to find, remember, we're trying to find a. I can find that a is equal to g over 0.4. I should have substituted g with 10 from the start, but you get what I'm trying to say. So a is going to be equal to 10 over 0.4, which is 25. So easy. Really, these questions are so easy. Wallah, wallah. يعني I'm telling you wallah. And they're the questions that may come in the written part. هلا the written part هو حاطط لك written وحاطط لك all the past papers. انت you have to solve them أكيد. Which I will record a video on tomorrow inshallah, maybe on Sunday. But there will be something on my channel to help you solve them. Question 3. Okay, هلا I think it's these easy definition questions. It gets easy until like question 20. It's where it becomes hard again. بس يعني يا رب مع STP loads. يا رب مع STP loads. يا رب loads. Oh my god. A body A exerts a force on body B, FAB, and body B exerts a force on body A, FBA. So أكيد it's action reaction force. These are action reaction forces, meaning that the action and the reaction are equal in magnitude, have opposite direction, and they act on different bodies. Obviously, they never act on the same body. Action reaction never act on the same body. If you go to my notes, memorize everything from here until here. Okay, these are all exam questions. Okay, question 4. I'm gonna start cutting until the question loads. Which does not contain any contact force, so they want a non-contact force. The only non-contact forces on Earth are the magnetic force, weight, and electric force. These are also called field forces, because they asked this before. Some people are like, what the fuck is a field force? A field force is a non-contact force. Question 5. They gave you a force on a particle of mass 10 kg varies with time. So this is the force. F is in newtons and T is in seconds. Initially, the particle is passing through the origin at 1 meter per second in the positive direction. Okay, what is this? Select the graph that shows the variation of the acceleration of the particle with time. As time increases, obviously the value of the force is going to increase. صح? If you increase the time, if you're increasing what you're multiplying by, then of course you can increase the value of F. So as time increases, the value of the force increases. And أكيد, if the force increases, F is equal to ma. Increase the force, what's going to happen to acceleration? It's going to go up. The velocity of the particle after 2 seconds of motion is what? So for this part, I doubt it's gonna come. It didn't come when it was in the CA last time, but you have to use integration. First you can find the acceleration is equal to what, and then integrate it, because velocity is equal to integral of the ADT. Okay, let me find acceleration. Acceleration is equal to force over m. The force is what? Okay, force is, distribute this. You're gonna get minus 10 plus 8t. Minus 10 plus 8t over the mass, which is 10. So you're going to get minus 10 over 10 is minus 1t plus 0.8. Minus 1 plus 0.8t. ما في t here. Okay. طيب, you're going to get, this is your acceleration. Velocity is equal to integral of ADT. Integrate minus 1 plus 0.8t with respect to time. You're going to get minus 1. When it's just a constant, you just add the letter beside it. And then this one, you take the 0.8 down and the t, add the power and divide by the power. And always remember plus c. Plus c is your initial velocity. Is it given? Yes, it is. It's 1. Okay? So you're going to get minus 1t plus 0.4t squared plus 1. So you're going to get, put this in your calculator, minus 1 times, at 2 seconds, 2 plus 0.4 times 2 squared is 4. So I'm going to put 4 plus 1. You're going to get 0.6. Question 6. A cyclist of mass 70 riding on a bike of mass 15 accelerates at 0.8. What's the force? The force is equal to mass times acceleration. So 70 plus 15 times the acceleration. Right? It has to be the system. They ask for the system, so you add both. So 85 times 0.8, and you should get 68. Question 7. The acceleration of free fall on Mars is 3.7. So g of Mars is equal to 3.7. طيب, if the weight of some science equipment on Earth is 250, what's the weight of this equipment on Mars? W is equal to mg. Okay? G of Earth is equal to, do you use 10? I think you use 9.8. Okay, 9.8. So can you find the mass? Yes, you can. Okay? Yeah, so you find the mass because we want to find the weight of the equipment on Mars. The weight on Mars is equal to the mass times the g of Mars. I need the mass. How do I find the mass? We know on Earth it's 250. So 250 is equal to the mass of the object times the g of Earth, which is always 9.8, unless given otherwise. So you're gonna get mass is equal to 250 divided by g of Earth, so 9.8. 50 divided by 9.8 multiplied by g of Mars, which is gonna be 3.7. We found the mass times g of Mars now, times 3.7. You should get 94 newtons. If you used, let me see, if you used 10, you're gonna get 25. 25 times 3.7. Yeah, so I would prefer you to use 9.8, okay? حتى if you want to be more exact, use 9.81. If it's a written part, and it's not given in the question, you can use g equals 10 or g equals 9.8, and whatever answer you get using that value of g will be given correct. Of course, if you did the correct steps. Like question 8, the tendency of moving object to carry on moving is called inertia. Always the tendency to continue whatever its motion, to continue undisrupted, continue with the state of motion that you began with, is called inertia, and the physical quantity of it is mass. More mass means more inertia. Okay, this was a question that came in the CA in term 1 week 9. A person is pushing a cart with a force of 50 newtons to the left. What is going to be the force of the cart on the person? Obviously, it's going to be the reaction force. So 50 to the left, the reaction of that will be 50 to the right. Question 10. Okay, I think they want you to resolve forces here. Yes, 3 up, 5 down. Okay. The magnitude of the vertical component. Okay. أول شيء Vy, of the force, Fy net is going to be equal, let's call this F1, F2, and F3. Is equal to F1 y plus F2 y plus F3 y. F1 y is just 3 newtons because it's acting vertically upwards. So you can just say 3 plus F2 y. F2 y will be 5 cosine 37. Or if you don't want to use 37, you want to use the angle with the horizontal, because until you're used to using sine for y and cosine for x, you have to do 90 minus 37, which is 53 degrees. What do you want? Do you want to use F2 cosine 37? Or do you want to use F2 sine 53? Whatever you want. Honestly, if I see the angle with the y-axis, بسرعة, I don't bother doing 90 minus. I'm going to waste my time. I'm going to, بسرعة, fast, I'm going to do that cosine is for y and sine is for x. You swap them. You know, when the angle is with the vertical, it's different. I'm going to use 37. And I advise you to learn how to use the angles with the vertical. You know, I'm not going to tell you how to, I'm not going to show you how to use 53. Because later on with weight, you're going to use, I don't want you to waste time. Sorry, if you see it with vertical, swap them. Use cosine for y. Okay? F2 y will be 5 cosine 37 plus F3y. F3y is going down, so it's going to be minus 8. It's going vertically down, so it's going to be minus 8. So you're going to get, it should be 1. Let's see. 3 plus 5 cosine 37 minus 8. You should get negative 1. They said the magnitude, so they just want 1. Okay. The positive answer, they just want positive because it's the magnitude. How about the horizontal component? Fx net is equal to F1 x plus F2 x plus F3 x. F1x, let's see. F1x, 0. F3x, 0. So we can just cancel these. F2x, why is it 0? Why is it 0? Man, it's going vertically down, vertically upward. In other words, theta here, the angle here is 90, cosine 90 is 0. And the angle here is 270, cosine 270 is also 0. Okay, why 270? Because 90, 180, 270. Anyway, so that's why F1x, F3x is 0. I just proved it for you in 3 different methods. F2x, how much is it going to be? The angle's with the vertical. So F2x will be what? 5 sine 37. Okay, so 5 sine 37, it should be positive answer. 3. Yes, the magnitude of the horizontal component, he said magnitude, so we just take 3. What is the net force? Net force is radical fx squared plus fy squared, so 1 squared plus 3 squared. You get 3 point to the nearest integer, 3.2. I mean, there's no other answer that you could choose here. Rounded 3.2. Question 11. A body of mass 0.2 kilos, initially at rest, is pushed with a force of 5 newtons for 3 seconds. What is the acceleration? F is equal to ma. Acceleration F over m. 5 divided by 0.2 is 25. The final speed of the body. If you're accelerating with 25 meters per second squared for 3 seconds, how much is the speed going to be? V, you're accelerating with 25, at plus u, right? Instead of u, it's starting at rest. Acceleration times time, 25 times 3 seconds is 75. So easy, يعني 75. شو بدك أحلى من هيك? Always know if you're pushing with a constant force, يعني أكيد the acceleration won't change because F equals ma. Obviously, the mass of the object is not going to change. So obviously, if you don't change the force, then the acceleration will not change. Did they say anything about increasing the force? They didn't say anything. So the acceleration will not change. Two forces of magnitudes 10 and 25 are exerted. The smallest horizontal net force they can exert. The smallest force they can exert, net force, net force means when you subtract them or add them, right? The only case where you'd have the smallest net force is if they were in opposite directions. So if it was 25 here or 10 here, this is wrong. The arrow for 10 should be a bit smaller. Okay, like this. Okay, this would be the minimum case. This is the smallest force they can produce. Any case would be 15 in this case, because 25 minus 10. The two forces are now placed to make an angle of 130 degrees between each other. The net force on the particle is what? قول هيدي هون 25. هيدي هون now 130 degrees. فهيدي 90 هيك 130 degrees. 10. أنا how am I gonna draw it for you؟ هرسم لك y axis وهيدي هون x axis. Okay. طيب. Obviously, we're going to resolve it into components. To find the net force, you need fx and fy. Fx is going to be equal, let's call this f1, and this is f2. f1x plus f2x. Is a هيدي 130. How much is this angle going to be here? 50 degrees. So the angle with the horizontal is 50 degrees. f1x is going to be equal to the force. Is it going to the left? Many people do it in a different way than I do it. I don't like the way they do it. And I use this way. I've been taught it since grade 10. Since it's going to the left, yani it's negative. The F force is negative. How the force is negative force cosine angle. Why negative? Because it's going to the left. The force is 10 cosine 50. F2x, it's on the horizontal, so it's just going to be 25. So Fy now, let's do Fy, is going to be F1y plus F2y. F2y is 0 because it's on the horizontal. F1y will be how much? How much is the angle here? It's هيدي 50. هيدي هتكون 40. Right? How much is the angle here? It's going up, so it's going to be positive. So F1y, it's positive. Then sine. Why sine? Because I'm using, or حتى you don't even need this angle. عادي. If you still have this 50, it will be sine 50, right? Force sine angle gets you the y component. هلا let's find our Fnet. Fnet is going to be radical fx squared plus fy squared. So radical fx 25 minus 10 cosine 50 squared plus 10 sine 50 squared under the brackets. Let's put this in fast. Radical brackets 25 minus 10 cosine 50 squared plus 10 sine 50 squared. 20 to the nearest integer. I thought to one decimal place. To the nearest integer, it will be 20. Question 13. Okay, what is the magnitude of the resultant forces of these three forces to the nearest integer? 0? Really, 0? Let me see here. Okay, I guess we obviously have to solve it. So this is, we can resolve this أول شيء into f1. Let's resolve it into its components. So we're going to get f1x. It's 5 cosine 36.87. And f1y will be 5 sine 36.87. And let's do this on our calculator. You're going to get, let's round it up to 4. f1x is equal to 4. f1y, it should be 3. I think it should be 3. If this is 4, 36.87. Yeah, 3. Okay. We know f3x is equal to minus 4 because it's going to the left, and f3y is equal to 0 because it's just on the horizontal, right? f2x is going to be equal to 0 because it's going vertically downwards, and f2y is going to be equal to minus 3. Let's add them all up. Add all of our x components. 4 minus 4, that's 0. Plus 0, 0. So 4 minus 4 and 0 cancel. our y's. 3 plus 0, that's 3. 3 minus 3 now is 0. So they all cancel out and you have 0 net force. Question 14. A spring has a constant of spring has spring constant 50. How far in meter must the spring be pulled in order to produce a tension of 75 newtons? Okay, you should know that Hooke's law is F is equal to kx. Okay. We want to find x, the displacement. We want to know x, the spring. The force is 75. The spring constant is 50. So, sorry, I have to rearrange it. To find the x, we take k to the other side. You can get F over k. The force is 75. The spring constant is 50. When you divide these, you get x is equal to 1.5. ولا أبسط من هيك. Like these questions are direct applications of forces. 1.5. Question 15. Okay, this is هلا بلشنا نفوت بالصعب شوي. A particle of mass 5 kilograms is projected at 3 meters per second up a rough inclined plane elevated at 37 degrees above the horizontal. The coefficient of friction is between the particle and the plane is 0.3. UG equals 10. Here عطوك الدايجرام هيك. The force of friction on the particle with the magnitude of acceleration of the particle. Any step, any question, they want you to find the force of هيك شيء. I always tell you, step 1 is draw your FBD. What's my FBD gonna be like? If you have an inclined plane, it's always easier for me. On my scratch paper, I just draw the inclined plane. برسمها هيك. حط إنه هون 37 degrees. طيب, what's the first thing I draw? I draw my normal. And I draw what? The y-axis, right? Why is the normal like this? Because it's always perpendicular. How about the x-axis? Again, perpendicular to the normal. طيب, I should put y here, not down. Okay, this is your first step. The second step is what? Draw the weight. How do you draw the weight? You go to your object, or you go vertically downwards. The weight isn't perpendicular to anything, it's vertically downwards. طيب. Now I'm going to show you. The angle here is how much? 37. Always. Don't be confused in the exam. The angle between the weight and the vertical is always equal to the angle of the inclined plane. Okay, it's a geometrically proven. You don't have to tell your examiner why or your corrector why you got 37. Just draw it. So you now have your weight looking like this. أنا يعني people they like to draw and continue off of this. بس أنا like I tell you بحسها كتير. It's too much going on at the same time. فأنا I take it or I just rotate it a bit now. So I have my x هيك. I have my y هيك. I just draw my weight باخدها هيك برسمها هيك. How much is it? 37 degrees. طيب, okay. Now we continue drawing all our forces. عندك النورمال up. وكمان عندك friction. نحن what did we say? We said here the particle is projected upwards. If the projected is projected upward, حتى عطوك ال direction. In what direction would the friction be? أكيد to the right. Yeah. So you continue drawing your forces. نحن here we're not done. People will think, oh خلاص I'm done, yeah? بس لا. Here are two common mistakes some students will make. In your FBD, they're going to draw a force to the left. Okay, they didn't say it was pushed with a force of 5 newtons. They didn't say anything. They just said it's projected at 3 meters per second. We didn't say I pushed it. We didn't say anything like this. Another mistake students will make is they're just going to continue solving like this. Okay, طب حبيبي, this W, you have to resolve it. Anytime you have an angled force, you always have, on your FBD, you have to show it's equal. You have WX and WY. We finished our first step of drawing the FBD. What did I tell you always the second step? Your sigmas. Sigma أول شيء your sigma. Sigma Fy. Is it equal to 0? Or is it equal to MA? Let's see. Is my object going up and down? Is it going up and down? لا. So it's going to be equal to 0. What are my Y forces? What force do I have vertically? When I say equal to 0, always what's down is equal to what's up. So the weight of the Y component of the weight is equal to the norm. This is equation 1. طيب. Let's try now the sigma of fx. Is it equal to 0? Is it equal to ma? Let's see. Is it moving? Yes. They said it started at 3 meters per second. How do I know it's accelerating? I'm going to tell you how you won't know it's accelerating. You won't know it's accelerating if they told you constant velocity. Also, you won't know it's accelerating if it's staying at rest. Okay, these are the two keywords you're looking for to know if it's not accelerating. Here, they said it's projected at 3 meters per second. Okay, you guys know it's going to begin to decelerate, right? It's going to begin to decelerate as you go up because it's decelerating. Because of friction, it's going to oppose its motion. It's going to start decelerating. So, okay, now we have an acceleration. Type, what are my horizontal forces? ما عندي شيء except Wx and F. Sigma means add. So, Wx plus F is equal to MA. If this was a written part, you must say Fk. Okay? Why am I saying Fk? Because it's at motion, so it's called kinetic friction. طيب. Okay. What are they asking for here? We have two equations now. Wx plus Fk equals Ma, and we have Wy is equal to N. So we have two equations. طيب. Part A, they're saying what's friction? Friction is equal to mu times N. Okay? We have mu, the coefficient 0.3. So it's going to be equal to 0.3 times N. Here's the tricky part. Where's my N? Well, if you look at your equations, we actually found N. It's equal to Wy. So 0.3 times Wy. Now you're going to tell me, Walid, what is Wy? Okay. Wy is the Y component of my weight. Weight, it's the Y component of my weight. How do you find the Y component of a force? Wy is equal to W cosine 37. Why cosine, guys? Because it's with the vertical. This is why I told you earlier, I want you to get used to knowing how to use when the angle is with the vertical. I don't want you to waste time and do 90 minus 37. So the angle is with the vertical, بسرعة, W cosine 37. And what is W? W is equal to mg. So we're going to substitute with mg cosine 37. And what's mg? 5 times 10. So 50 cosine 37. So you're going to replace this with 0.3 times 50 cosine 37. And you're going to get 11.9, I think. 0.3 times 50 cosine 37. 11.2. The nearest integer, it's 12. Okay. So, if you want my honest opinion, Anna, instead of writing W, okay, wait. I solved wrong. If this is written, you must put vector symbols over Fy and 0 and over this. You need to put vector symbols over these, and on your diagram, you have to put vector symbols. Okay? Don't forget about this. Okay? Type. If you want my honest opinion, to make your life a bit easier, instead of writing W, and I started to write mg, which is the same thing, and the corrector actually likes it more when you write mg, okay? Because he has to correct less stuff, okay? So if you just say mg instead of W on your diagram, if you just say mgy, mgx, mg here, it's completely correct, okay? So and instead of that, I use mg, and I just see mg cosine 37, and it just makes my life way easier, okay? Part B, the magnitude of the acceleration of the particle to one decimal place. This is why in equation, I did the first step. I did both sigma Fy, sigma Fx. This is why I did this all. Because even if you might, only for part A, you might need like this part. For part B, you're definitely going to need everything else, okay? This is why I finish the FBD, I find both equations. What do they want? They want acceleration. Let's see. You go back to your accelerations. Always for these types of questions, you go back to your equations. Do I have acceleration in any of them? Yes, here. When they're asking for something, you're going to rearrange the equation so that you get that something. How do I find acceleration? I have to divide by m, right? So I'm going to get Wx plus Fk over m. Type. What's Wx? Guys, what's Wx here? It's Wx is equal to, since the angles with the vertical, it's going to be W sine 37. Okay, so mg sine 37. So 50 sine 37. This is why, if you start from mg sine 37, sorry, you can just, mg 50 sine 37. So you're going to get 50 sine 37 plus Fk. We found the friction in part A. So plus 12 over the mass 5. Again, I have to go get something. But you do this, I think as I mentioned this. Wx plus Fk, just this plus Fk, which we found is 12, divided by the mass of the object, which is 5. On the calculator, plus 12 over 5, 8.4. The distance traveled by the particle up the plane before coming to rest is how much? Here we have acceleration, okay? It's UARM, because we know that the acceleration is 8.4, okay? And we have that the initial velocity is how much? 3. Okay, But here's the thing, yeah? The acceleration here should have been negative. Before continuing, I should have gotten a negative answer. Make your answer negative because it's wait. No, it's correct. It's correct. You're accelerating in the direction of the yeah, it's correct. 8.4. The distance traveled by the particle up the plane before coming to rest is how much? It's UARM because we have initial velocity, we have final velocity, we have the acceleration. We want to find the distance. So we have u, we have v, we have a. We want to find the distance x. What do we use? V squared minus u squared equals 2ax. You're gonna get v squared 0 because it's rest minus u squared. So minus 3 squared equals 2 times 8.4 times x. You're gonna get a negative answer. I hope someone in the comments can correct me as to why it's not why it's positive. Is it just because distance is positive? I don't know. But obviously take 2 times 8.4 to the other side and you should get 0.5, negative 0.5. So you get negative 0.5, which obviously since it's to one decimal place it's going to be 0.5 and it's positive because of distance. I hope someone can correct me. Is there something I did wrong? Should I have gotten a negative answer for part B? I'm not sure. I think I should have gotten it's equal to minus MA because it's in this direction. But yes. I should have. This is why, guys. FBD always draw the direction of your acceleration. Since these forces are to the right, that means acceleration is to the left. That means it's equal to minus MA. And you would have gotten A is equal to minus 8.4. And they asked for the magnitude, so that's why you take positive 8.4. So if I used minus 8.4, I would have gotten positive. Yeah. Okay, that was the mistake I made in part A. So always draw the A with the arrow of the acceleration. After the particle reaches the highest position, it begins to slide down. The magnitude of the new acceleration of the particle is A2. Complete the following comparison using a sign from the table. Okay. Here, when it was going up the plane, it had the weight resisting it and the friction resisting it. Now, you know that the weight acts on the right. Now, basically, the ball reached the top and it's now starting to slide down. How is the acceleration going to compare? Acceleration is obviously going to be bigger because when it was going up, it had two forces resisting it. Now, when it's going down, it's going to have the weight pulling it forward, but the friction pulling it backward. So here it had two forces resisting it. Here it had only one force resisting it. So obviously, the second acceleration now, the new one, is going to be greater than the first one. Okay. Question 16. Okay, two particles A and B of masses 2 and 3, respectively, are connected by a light inextensible string. Inextensible string means tension is equal to tension. Okay, over a light smooth pulley P, so we're ignoring friction. With the string taut and perpendicular to line of intersection, the system is released from rest and accelerates at 4.5. Take G equals 9.8. What's the tension in the string? Okay, again, draw the FBDs. Okay, let's start with FBD of A. Okay, we have A. Draw the y-axis. Draw the x-axis. Let's see. A, we're going to start with drawing the weight. It's obviously equal to mg, which I'm just going to write now first. What is it? It's mg. Okay, I'm just going to say mg. Why is it straight? Because it's straight. We also always have the normal push. If it's on a surface, you have the normal push. Okay, we have the tension is pulling it. System is from rest and accelerates. So it's accelerating to the left. Obviously, accelerating to the left because B is heavier. B is 3 kilos. So it's going to accelerate to the left. So T is here, acceleration to the left. Right. This is for block A. I'm going to also draw for block B because you need it for part B. For block B, it's an inclined plane. So what do you start with? Draw your y-axis, always perpendicular, and draw your x-axis. Then draw your weight, right? It's always going downwards. And then take it and rotate it. Now, this is the step I like to do. I take it and rotate it. Other students disagree with me. Many students, they don't like the way I do it, but this is how I do it. I don't like working curved. يعني how do you guys work and it's هيك, it's inverted. ما بحب. But then I draw the weight, which is just to the left, صح? Just to the left. And what's the angle? It's theta. Okay, let's keep it as theta. طيب. I think this is the question where you need to use tan. I'm not sure. Anyway, so this is mg. Okay, let's see what else do we have. We always have the normal going up, right? And let's see, we have the tension that's pulling it. Is it pulling it to the right? Yeah, obviously the tension is just going to pull the block to the right. So we're going to put tension here. Okay, I can't think of anything else. Yeah, since there's no friction, there's nothing else here. Okay, let's draw the direction of the acceleration to the left. Let's see now. Start for block A. For block A, let's start with sigma Fy. Is it jumping up and down? Is it moving up and down? No, it's just accelerating to the left, so it's equal to 0. So what does that mean? Mg is equal to n. Okay, what's up is equal to what's down. What's down is equal to what's up. Always when equals 0, that's the case. Down equals. How about sigma Fx? Since it's accelerating horizontally, it's equal to ma, right? What are my horizontal forces? I only have tension. Tension is equal to ma. So this is my first equation. This is my second equation. Let's go here. Now for block B. Sigma Fy. Is it jumping up and down? No, so it's 0. So what does that mean? What's down is equal to what's up. I made a mistake here. I should have resolved this mg into its components. mgy and mgx. If you don't do this, oh, I also forgot to put vector symbols. Guys, oh my god. You lose quarter for no vector symbols. Okay, please don't forget. Okay, you need vector symbols. Vector symbols, vector symbols, vector symbols. Okay, command here on the forces, put vector symbols. I keep forgetting, and I don't know why. Okay. Okay. Sigma Fy equals 0. That means what's down is equal to what's up. If I didn't write mgy, I probably would have been confused and say, oh, there's no force acting down. But you have to resolve the component into x and y, right? So mgy, so what's down? Mgy is equal to n. Okay, this is my first equation. Let's start. Fx. It's accelerating to the left, so it's going to have ma. What are my forces? My horizontal forces are mgx and t. So let's see. It's accelerating to the left. This is how I write it. If it's accelerating, how I do it is the stronger force is going to the left, and x is stronger than t. Mgx, I write it first. Then I subtract the other force. Okay? See, why do you say sigma? Because you add the forces. So people will put plus. But since it's in opposite directions, one's going to be plus, one's going to be minus, right? Which one's plus, which one's minus? I always start the stronger force is the positive one, and the negative force is the smaller one. K is equal to ma. This actually should have been my third, and this is my fourth equation. Let's see. The tension in the string. We know the tension is equal to ma. The tension is equal to ma, so immediately you can just do 4.5 is the acceleration times the mass of, we're talking about here, what block? Block A, right? I should have written block A here. Massive A, massive A. Here I'm talking about massive B, massive B, massive B. Type block A, what's the mass? It's 2 kg. So 4.5 times 2, which is equal to 9.0 Newton. People say, oh, part A, you don't have to do all that. I'm telling you, I always do this because I also need for part B. What's the angle the inclined plane makes with the horizontal? Let's see. Now we have here mgy is equal to n, right? What is mgy? I want something with theta. How I'm going to get that? I have x and y components. You guys don't have x and y components. And there's an angle involved. Mgy is going to be equal to mg cosine theta, right? Why cosine? Because the angles with the vertical. So instead of saying sine, we use cosine. Mgy is going to be mg cosine theta, when this is equal to the n. طيب. Here, I should have written, I keep on forgetting to say MB, MB. Why MB? Because here, block A, block B. Don't get confused, because now you're going to see what I mean. So MB cosine theta, it's equal to n. Don't we know? Oh, wait, never mind. Actually, you know what? Let me not use this step. Okay, I'm actually going to use this one here. I'm going to use MG, MB, GX. I'm going to use this one here. I'm not going to use this one. Because this is it's not going to lead me anywhere. What I just wrote, it won't take me anywhere because I don't know what n is. But this one here, I actually found out what t is from part A. So that's basically they're telling you a hint. Oh, you're actually you're gonna need part A for part B. Which one here has t and has an angle? Is gonna be this one. Mgx. What is mgx equal to? Mgx equal to mg, since it's x sine theta, right? Type. So mg sine theta minus t, so minus 9 is we're talking about B, huh? Block B is equal to mass of B times A. What's the mass of B? 3 kg. Okay. The acceleration, what is it? It's 4.5. If you're writing this in a written, since above the word inextensible string, you say inextensible string means tension is equal to tension and acceleration is equal to acceleration. Okay. T1 is equal to T2, A1 is equal to A2. Write it like this, just so the corrector knows what you're doing. MBG sine theta. You can now solve this very easily. MB is, we said 3. G, we said it's 9.8. sine theta minus 9 is equal to 3 times 4.5. You put this in your calculator, you're going to get theta equals 50. 3 times 9.8, right? Sine theta. So you get 29.4. I just want to make my life a bit easier. 29.4. Take 9 to the other. So 3 times 4.5 plus 9. 3 times 4.5. Taking 9 to the other side, so I do plus 9, will be 22.5. So 29.4 sine theta is equal to 22.5. Divide now by 29.4 and then do shift sign. And you get 49.9, which is 50 degrees. Question 17. Two particles of respective masses m and 3m are connected by a string s and pulled by a force F along a rough horizontal surface. Rough يعني في friction. The system then accelerates at the rate of 6a is equal to 6. The coefficient of friction is 0.6, so mu is equal to 0.6. Take g equals 10. طيب. They want the tension in S and they want the force. What do we do? FBD. Let's start with mass m. Draw the y-axis. Draw the x-axis. Take your FBD, right? We start أول شيء with the mass, with the weight, sorry. Let's call it mg. Okay, and we always have the normal push. What forces do we have acting on it? We have a rough horizontal surface, so we have, since moving to the right, the friction is going to be to the right, to the left, opposing it, right? Okay, what force do we have to the right? Since we have a string pulling it, and there's tension. Okay, we know that the tension here is equal to the tension here, صح? Okay, you're going to need that later. But for now, this is block, let's call this block 1. How about block 2? Again, FBD, y, x. We have شو عندك؟ دايما عندك الويت. It's going to be mg, but what's the mass here? It's 3m. So I'm just going to call it 3mg because that's going to help me out later. Okay, and أكيد عندك الnormal, right? And then you have the tension that's pulling it to the left. Why pulling it to the left? And if you're moving to the right, the string is going to pull you back to the left, right? And you have the force F that's pulling the object to the right because we're pulling this whole string to the right. So now we have our عندك friction كمان. Of course, you have friction opposing the motion. Now we have our FBDs, we can solve very easily. The tension in the string. We're going to start here. Resolve our sigma Fy. Sigma Fy is 0 because it's jumping up and down. No. So mg is equal to n. Always what's down is equal to what's up. طيب. Sigma Fx is equal to ma. Why is it ma? Because they said we're accelerating, right? What is my horizontal forces? T and Fk. Where am I accelerating? To the right. So the stronger force is T. So I write it first. T. The other one's in the opposite direction. So minus Fk is equal to the mass times the acceleration. This is my first equation. This is my second equation. Ya Allah. It's my second equation. Here, sigma Fy is equal to 0 كمان because it's not jumping up and down. N is equal to 3mg. That means, now then this is my third equation. Then, sigma Fx, are we accelerating? Yes, I was supposed to write this. So it's going to be vector symbols, 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 vector, خلاص, okay. Sigma Fx here, since we're accelerating, mass times acceleration. Okay, what are my horizontal forces? F, we're accelerating in the direction of F. So F is the stronger force. Minus, what else do I have? T minus Fk. Minus T minus Fk is equal to the mass times the acceleration. What's the mass of this object? It's 3m. Okay, I'm just going to write it now so you don't get confused, okay? Please pay attention to this. The mass of the object here is 3m, so write 3m. 3m times the acceleration. Let's do some substitution. Actually, we want the tension of the string. Which one do you think is easier, to use this one or this one? And I prefer this one. It looks way easier, right? T minus Fk equals ma. What is force? What is friction equal to? It's always equal to mu times n. What is n? Mg. So it's going to be mu times mg. And what is mu? 0.6. So 0.6 times mg. Okay, we don't really have anything else given other than the acceleration. And yeah, you're going to use it here. So T minus the friction, 0.6 mg, is equal to ma. Again, the mass, they kept it to us as m. What's the acceleration? 6. How do you find T? We just take 0.6 mg to the other side. But I can continue simplifying this. I should have written that G is equal to 10. And I should have done here N times mg as the mu times mg, 0.6 times m times g, which they said is 10. I should have done this. So you get 6m. Okay, so I should have done minus 6m here. Equals m times acceleration, which is 6. Take 6m to the other side, you're going to get T is equal to 12m. So what is T equal to? It's something m. What is P? 12. Okay, now Q. Q they want is the force F. Where do I have the force F? I have the force F here. طيب. I know the tension is 12m. So F minus 12m minus Fk is equal to 3ma. This is where many students will make the mistake. They're going to put Fk as the same value here. No. Why no? Because I have a different n here. We're talking about a different object. The friction is not the same because they have different masses. Okay, let's start our substitution. F minus 12m. Can I reduce Fk to something else? Yes, I can. What's friction equal to? Mu times n. Mu, what is it? 0.6. Times n. What is n here? We got it as 3mg. So 3m times g, which is 10. So you're going to get 18. You're going to get 18m. 0.6 times 10 is 6. 6 times 3, 18. So 18m. So minus 18m is equal to 3ma. 3 times m times the acceleration, which is 6. So you're going to get, take it all to the other side. You're going to get F is equal to 3m times 6 is 18m plus 12m plus 18m. Because you took it all to the other side, you're going to get F is equal to 48m. So F is the form of something m. What is that something? 48. Question 18. A body of weight 30 newtons lies on a rough horizontal table. The body is gently pulled to the side using a string inclined at 30 degrees to the horizontal. So, and the cone, the body, I'll draw the FBD in a second. The tension is 18. Assume the body moves with constant velocity. So A is equal to 0. This is very important. They want the friction and the normal. Very easy. What do? Draw FBD. What's the first thing? Weight, which they gave it to us, 30. Okay, you know, actually, no, let me continue drawing the y-axis. Then I'll draw the weight and then x-axis. Because you're going to need this for later. Always draw your y and x-axis. Halla, I draw my weight. It's going to be 30. That's my first force. What other force do I have? We know that's pointing to the side at a string at inclined 30 degrees. So, yani هيك string, which is 18 newtons, and they said it's inclined at 30 degrees. They said that it is on a rough horizontal table. Okay? It's rough. So, في what? FK. طيب. Symbols, vector symbols. What's one thing I'm missing? What did I always tell you? If you have an angled force, what do I have to do? I have to resolve it into its components. So I'm going to call it, let's say, tension. I have to call it into Tx and Ty. Ty hon with Tx hon. Okay, let's start with our sigmas now. Sigma Fy. Is it moving up and down? No, so it's equal to 0. So what is my forces of the y component forces? Ty and the weight. So what's down is equal to what's up. Always when equal to 0, and what's down is equal to what's up. So Ty is equal to 30. So that's nice. Wait, no, مش معقول. This is wrong. Yes, I forgot. I'm saying I forgot something. Oh shit. It's Tx. What did I raise here? I don't know. Okay. I forgot. If you have weight, always you have what? Normal push. Forgot about this. So now, let me continue. Sigma Fy is equal to 0. What are my vertical forces? What's down is equal to what's up. So 30 is equal to what's up. Ty plus n, right? Ty plus n. Okay. This is equation 1. Equation 2. Sigma Fx now, is it equal to ma? No, we said constant velocity. A is 0, so there's no acceleration. So it's constant. Even though it's moving, it's still 0. You have to see if it's accelerating or not. What is my horizontal forces? I have Tx and I have Fk. So Tx is equal to Fk. When it's always equal to 0, the ones on the opposite direction are equal to each other. طيب. Now, I can do this very easily. This is my second equation. What do they want? They want the friction force. We know that friction is equal to Tx. And we know what is Tx equal to? It's equal to the tension times cosine of the angle. This time, why is it cosine? Because the angle is actually with the horizontal. So I don't switch them. I use the original ones, cosine for x and sine for y. So it's going to be 18 cosine 30, and you should get 15.6. I'll do the calculation at the end. So Fk is equal to this. Fk is equal to this. That's the first one. Then they said the magnitude of the normal. What's the normal? Normal is equal to, if I take Ty to the other side, 30 minus Ty. And what's ty equal to? Ty is equal to t sine the angle 30, right? So it's going to be 30 minus 18 sine 30. And this one, I'll tell you from now, it's 21. And this one here should be 15.6. If you do it on a calculator, let's just do it. 18 cosine 30, 15.6. The other one's 21. I'm telling you it's 20 because sine 30 is 0.5. 18 times 0.5 is 9. So 30 minus 9, 21. Question 19. A cart moving a rough horizontal surface will stop. What makes it stop? Of course, friction. And this friction converts the kinetic energy into thermal energy. Easy. Question 20. A block of mass 5 kilograms is pushed along a rough horizontal surface. The coefficient of friction between the block is 0.3. Take G is equal. The pushing force needed to accelerate the block. طيب. FBD. Y-axis. X-axis. أول شيء we start with our weight and normal, right? Yeah. Weight. mg. 5. I'm just going to give it to you. mg. 5 times 10. Let's just do it now to save ourselves some time. And then normal up, always. Being pushed to the right. Let's say it's pushed to the right with force F. Was pushed back with friction, because he said friction. Let's see. It wants to accelerate. So I'm going to start with sigma Fy. Is it jumping up and down 0? No. So N is equal to 50 newtons. So N is equal to 50. What's down is equal to what's up. Okay. Sigma Fx is equal now, since we're accelerating, ma. What are my horizontal forces? It's accelerating to the right. So F is going to be bigger. So F is bigger. So Fk is smaller. So we do minus Fk. Equal to the mass. What's the mass? 5 times the acceleration. I did something wrong. No? Oh, yeah, the acceleration is given 4. I don't know how I didn't see that. Yeah, 4. Okay, so F minus Fk. What is Fk? Fk is equal to mu n. Why you need to do the first step is so you know what n is. Mu is 0.3. N is 50. Because you can't just simply say 0.3 times 50. You have to show the corrector that 50 is equal to n. 0.3 times 50. You get 15. So you're going to get Fk is 15. So F minus 15 is equal to 20. So you get F is equal to how much? 35. Very simple. Question 21. A lamp hangs down from the ceiling by a chain. If the action force is the upward pull of the chain on the lamp, then what's the reaction? Instead of going up, it's going to be downward. Instead of the chain on the lamp, it's going to be the lamp on the chain. So easy. Just solve them. A block of mass 10 is sliding down a plane inclined at 37 degrees with the horizontal. I'm going to draw it for you like this. It's sliding down, so it's accelerating to the right. Okay. The block is sliding down at a constant speed, A equals 0 to 0. The normal push, force of friction. Yeah, let's hear fast. Let's not waste our time. You know what? I'm going to give you a rule. I'll give you a rule from now. You can do this for any inclined plane question where it's not accelerating, where they tell you it's a constant speed. Only if it's a constant speed. Normal push is always equal to the force, or sorry, the weight times cosine of the angle. And the friction is always equal to the weight times sine of the angle. Okay. This works for any time. So I'm going to, obviously, if you put this in your written part, you're going to get spat on. Anyway, here. Always start with your y-axis for your FBD. It's y on LX. Right? طيب, your weight. كيف حتكون الويت؟ حتكون هيك. No? Going vertically down. So now you can know your FBD. Let's draw it. Always for the inclined plane, the first step is to do what I did there. Okay? Know where your weight is, know where your head is. Okay. You now know your weight is acting to the right. With what angle? 37 degrees. You have up what? Your normal. It's not being pushed with anything, so there's nothing except what? Friction. Type. Let's see. We have to resolve our weight into WY and WX. Vector symbols there. Okay, let's see. Sigma F, let's start with Y, is obviously equal to 0 because we're not jumping up and down. So what's down is equal to what's up. So WY, let's just say W cosine 37 because it's with the vertical angle. So you have to do cosine for the Y component. Is equal to what's up N. So W, the weight, mg, sorry, I'm going to write it. Mg cosine 37 equal to N. Okay, mg is 10 times 10 because mass is 10, g is 10, so 100 cosine 37 is equal to m, which is 80. Sigma fx now. Are we accelerating? No, so it's equal to 0. Again, vector symbols, huh? What are my horizontal forces? Wx, fk. So Wx is equal to fk. What's Wx? It's mg sine the angle, in this case is 37, is equal to fk. So 100 sine 37 is equal to fk. Do it now in your calculator. 100 cosine 37 for n, 100 cosine 37, 80, and then 100 sine 37, you get 60. Again, if it's a constant speed with no force being applied, inclined plane, you can simply use this rule. Okay? And this rule for the friction. You can simply use them. If they set constant speed. Two identical springs of stiffness 150 Newton meter are hanged from the ceiling side by side. A box of mass 3 kilograms is attached to both of them simultaneously. Use G equals 10. The equivalent stiffness of the system. Of course, if you have two 150s, what's the stiffness going to be? 300. The extension in either spring. Let's now see, they want the extension. So obviously I need to find the force, وكذا وكذا وكذا, right? I need to know what the force is, so I find the extension. Because, F is equal to kx. X would just be F divided by K. This is Hooke's law. Okay. Here they said the box is 3 kilograms. Okay, so okay, its weight will be how much? 30 newtons, because mass times G, 30. Let's draw the FBD. You have the weight. I'll just draw Y. There's no horizontal, but I'm just going to draw X because you have to. 30 going down. Okay, you have to draw it with an R. 30 newtons. Going up, or actually put weight. Okay, put weight. And going up, we're going to have, can we say normal? I guess you can say normal, right? It's the push from the springs. How can I don't know what to use. Please correct me in the comments, but I think I'm going to use tension actually, because it's a rope. The strings count as ropes. Correct me if I'm wrong. Type sigma Fy is going to be equal to 0, because we're not moving up and down. It's staying, it's hung, right? So what is my y versus my shoe? What are my vertical forces? W and T. So W is equal to T. So 30 is equal to the tension. So can but if you do sigma Fx equals 0, there's no x forces. Okay, what are you gonna do? Vector symbols. Type. Now you know that the force is 30. Can you now find the elongation x? Yes, you know the force is 30, so x is gonna be 30 divided by the spring constant. If you use 150, you're going to get it wrong. We have two springs. That's why they asked us part A to find the equivalent stiffness, 300. And you're going to get 0.1 meters, which in centimeters is 10. Question 24. Inshallah, these are easy, but I know one of them is not. Yeah, this was one. Okay, the pulleys in the below figure are massless and frictionless. It is given that M1 is 5 and M2 is 2. Take G equals 10. What is the acceleration of M1? What's the acceleration of M2? طيب. Okay, they gave us M1 is going down, which will pull M2 up, right? So let's see. Let's start with the FBD of, actually, I'll start with the FBD over here, of M1. Logically, there should not be any X forces, but see, obviously we have the weight, mg. M1 is 5, G is 10, so mg will be 50 newtons down. So let me just draw it like this. These are easy because you don't work with angles. 50 newtons. Then you have the tension that's pulling it up. Here, I think I'm not wrong. We're going to solve and see. But it's on M1, we have two tensions. So it's going to be 2T. Right? This is for block 1. How about M2 now? Let's draw M2. There's no other forces I can think of. There's no normal reaction because it's the tension that's pulling it up. And it's not being placed on any base. Now for M2, let's see. Again, draw your y-axis. Draw your x-axis. And let's see the forces. We have the weight, obviously pulling it down. Mg. 2 times 10, 20 newtons. Up, we have a force of T pulling it up. You have to say that the tensions are equal to each other because it's the same string, right? You have to see here now that the objects are accelerating, right? So sigma Fy is going to be equal to ma. For block 1, we're going to say m1a1 because they're different accelerations. Or for block 2, it's also going to be m2a2 because they're both accelerating. Also, they're asking us to find the acceleration. Fx, we don't have any fx, so we're going to skip this time. Sigma Fy is equal to m1a1. Where's the accelerating? Accelerating downwards. So that means the 50 is greater than the 2. So 50, then I say minus 2t is equal to the mass of a. What is it? A mass of 1, 5 times the a. Then here you're going to say sigma Fy is equal to m2a2. So that means, what are the forces we have? T and 20. It's going up, so that means T is greater than 20. So T minus 20 is equal to m2a2, so 2a2. For these questions, you have to know that a of the larger object, a2 of the smaller, this acceleration of the smaller object is always equal to 2 times a1 because it has one string. Here it has two strings. Okay, always know the one with less strings is going to be equal to 2 times this one. Hatta you can see in the answer, 2 times this gets you this. Okay, always a2 is equal to 2a1. In this case, why is it a2? Because a2 has one string, but the other one has two strings. Type. Knowing this, I can find an expression for a2, take it to the other side, and then substitute. Here we have a1, right? And substitute. a2 is going to be equal to t minus 20 divided by 2. Type. This is equal to 2 times a1. What is a1? Let's find it. a1 is going to be equal to 50 minus 2t over 5. This is just math. After you get these two equations, you can solve it in any way you want. This is the way and I like to solve. It's 50 minus 2t over 5. We know that a2 is equal to 2 times this. So a2, t minus 20 over 2 is equal to 2 times this. So 2 times 50 minus 2t over 5. Okay, so now you're going to find the expression for tension. Let's distribute, let's multiply by 2 on both sides to get rid of this fraction, Bedieschel fraction. Okay, you're going to get these cancel, and this is going to be 4. So t minus 20 is going to be equal to 4. 2 times 2 is 4. 4, 50 minus 2t over 5. Okay. You're going to get this, t minus 20. 4 times 50 over 5, how would you distribute this? Yeah, is equal to 4. Let me simplify what's inside then. First, 50 over 5 is 10, minus 2 over 5 t. Get rid of it, because split it up into two parts, huh? Okay, you're going to get t minus 20 is equal to 4 times 10, 40, minus 8 over 5 t. Because 4 times minus 2 over 5 is minus 8 over 5. You're going to get, take the t's here, take this here. T plus 8 over 5 is going to be 13 over 5 t is equal to 60. How would you find t now? I just took these to other sides, huh? What you're going to get now? How do you find t? 60 divided by 13 over 5. You get this. Let's say, what's as a fraction? 300 over 13. So t is equal to 300 over 13. Even though they're not asking for it, you're going to need it if it was a written part. They would always ask for tension. Can I find now a1 and a2? Yes, I can. a1 is 50 minus 2t over 5. So you go to your calculator. You go 50 minus 2 answer over 5. You should get 10 over 13. Right? Just substitute t with the answer. We got 300 over 13. 50 minus 2t over 5. How about m2? You can just do 2 times this. But even to prove to you that it's 2 times this, I'm going to go to m2. I'm going to substitute t. I'm going to show you that you're going to get this answer, which is 2 times this. T minus 20 over 2. So let's go back. Oh, by the way, if you have a calculator, go back to the answer you got and press equal. Yeah, press equal. And now answer is locked in as what you just got. So get t minus 20 over 2. So you get answer minus 20 over 2. And you get 20 over 30. Question 25. A block A, mass 3.5 kilos, rests on a smooth plane. This is block A, which is inclined at 30. A light inextensible string connects A to B. So when you say inextensible, that means T equals T and A equals A. Okay, T1 equals T2, A1 equals A2. Okay, which hangs free. The string passes over a small smooth pulley P fixed at the top of the inclined plane. The system is released from rest with the string taut and the hanging part vertical. Use g equals 10 meters per second squared. Okay, so let's draw the FBDs for both of these. I'm going to start with drawing for A. A, draw the y-axis, draw the x-axis. I don't know why I chose black, but yalla. And the weight will be going down like this. So let's rotate it again, because it's easier. And I always tell you for FBDs for inclined, rotate. Yalla, let's draw our forces. Hide the y, hide the x. I have the weight to the left, right? So it's going to the left like this. And the angle at day, 30 degrees. So this is W. We're going to dissolve it into WX and WY. Type, what else do we have? We always have the normal push going up, right? This is for block, it's called block A. We said block A, yeah? Block A. And did they say anything about friction? We said it's a smooth plane, no friction. Okay. Type, we said this. We also have the tension of the string, right? So the tension over here. Let's see. Now, block B. Let me draw block B. Block B is easy because we just have the weight and we just have the tension, right? So we're going to draw here, the weight here, and we just have the tension. And you can draw, you by the way have to make it y like this, x like this, even if it's just two forces. Okay, طيب, let's do it. Sigma f y here, what's it going to be equal to? 0. Is block A jumping up and down? No. So what does this mean? N is equal to wy. This is, I'm going to take this down. Sigma fy is equal to 0. N is equal to wy. Equation 1. طيب, sigma fx is equal now, it's accelerating, right? So m, how do you know it's accelerating? It's released from the rest and they're asking for acceleration. Yani, common sense. Okay. Fx is equal to ma. What are my horizontal forces? It's out of, where is it accelerating, to the left or the right? See here, obviously it's going to accelerate to the left because this one's heavier, but you never know. It depends on the angle. I'm just going to solve as if I don't know. Let's say it's accelerating to the right or not to the left. W, you're going to get, since it's accelerating to the left, put A like this. You get, that means this one's stronger than this. That means Wx minus T, صح? Is equal to the mass of A. I'm going to say 3.5. I'm going to substitute هلا. 3.5 times acceleration. What is Wx? Wx is equal to W sine 30, which is equal to mg sine 30. So it's equal to mass 3.5 times 10 sine 30. You have to say A, huh? Mass of A. So 3.5 times 10 sine 30, and you get 17.5. Okay, so 17.5 minus the tension is equal to 3.5 A. Equation 1. طيب. Equation هلا here. We have W is equal to T. Why? Because sigma Fy is equal to MA. Oh, it's not equal to T. Sigma Fy is equal to MA. Why? Because when you release it from rest, obviously it's going to accelerate upwards, صح? طب let's see. Sigma Fy equals MA. What are my vertical forces? W and T. Let's say it accelerates upwards, so T is greater than W. So it's going to be equal to mass of B times A. What's the weight of B? It's 1 kilo and G is 10, so mg will just be 10. So T minus 10 is equal to mass of B 1, A. So T minus 10 is equal to A. Second equation. So A is equal to T minus 10. So here, can I substitute T minus 10? Yes, I can. So 17.5 minus T is equal to 3.5 T minus 10. 17.5 minus T is equal to 3.5 T minus 35. You're going to take T here, 35 there. You're going to get 17. You're going to get 17.5 plus 35 divided by, I would say 4.5. 11. Whoa! 3.5 T plus T. I did something definitely wrong. 3.5 plus 1. You get 35 plus 17.5 divided by 4.5. Wait. I got it correct. But أنا here I found, Ya Allah. This is what I found here. I found T. T is equal to this, صح? So T is equal. T is equal to 35 over 3. نحن we said A is equal to T minus 10. They want A. They don't want T. أنا أهبل. So 35 over 3. Go back to it. I want 35 over 3. Yeah. Is my answer 35/3? No. I want 35/3. No. يا Okay, 35/3 minus 10, and you should get 1.7. هلا 1.6. Yeah, 1.7. Okay. So we found tension 35/3. So then you know that A is just equal to T minus 10. So 35/3 minus 10, which is this. Okay, and you can do it in this here, but this one's easier. Block A will move, obviously, since acceleration is positive, in the way we took it, that means it's going to move down the incline. The way we took it was Wx is greater than T. So that means Wx is going to, since it's positive, Wx is actually greater than T, that means it's going to move in the direction of Wx. Question 26, last question. Okay, very easy. An airplane is in air is increasing its altitude while moving uniformly forward. Okay, if it's increasing its altitude, that means y is greater, the y up is greater than y down, right? So y up is greater than y down. Moving uniformly forward, that means the arrows forward and backward are equal. Okay, makes sense. A block of wood is resting on a rough inclined plane. If it's resting on a rough inclined plane, that means it has friction. Like, let's say I draw the inclined planes like this. Obviously, the norm is perpendicular, the weight is going down, or the friction is keeping it up from falling. A block attached to a rope is lowered down at a constant acceleration. Okay, if it's a constant acceleration, means lowered at a constant speed, as a constant force. Block attached to a rope is lowered. Yeah, if it's lowered down, that means the one down is greater than the one up. Well, there's nothing, they didn't mention anything about X, fine, we're not going to choose anything else here. While a trolley is pushed across the rough horizontal floor with an increasing speed. If it's an increasing speed, that means the one on the right is bigger than the one to the left. And since it's rough, that means we should have something on the left, which is friction. Okay, with the ones up and down, even though they didn't mention it, you just have to say, because obviously there's the weight of the trolley and the normal of the trolley. Thank you so much for watching, and good luck.